Hi and welcome to how to create robot scenarios in MATLAB. In this video, we will explore how to use the robot scenario object from the Robotics System Toolbox to create and simulate robot scenarios. The robot scenario object allows you to create a simple simulation scenarios with static objects, robot platforms and sensors in a 3D space. It's a perfect tool for simulating and analyzing simple robotic systems. These simplified and low fidelity scenarios are also known as cuboid scenarios. These have several advantages. They are easy to set up, ideal for rapid prototyping, and faster in execution. Let's dive in by creating a new robot scenario. Imagine we are simulating a robot that moves along a set path equipped with an INS sensor that updates its data in real time. Let's create and simulate this scene using the robot scenario object. To start, in your MATLAB live script, enter scenario is equal to robot scenario. This command creates an empty robot scenario with default properties. You can see these properties on output window. The update rate property controls how often the scenario updates, while stop time determines when it ends. You can also set the reference frame. By default, it uses east north up and northeast down reference frames. You can also create the customizable static meshes, which can be defined as collision objects for obstacle avoidance. Let's set the update rate to 10Hz and simulation to end after 60 seconds. To visualize your scenario in 3D, use Show 3D of Scenario. It displays the scenario in 3D view. Next, let's add some objects to the scenario. You might include planes, boxes, spheres, etc. To add custom shapes or objects, use Add Mesh function. For example, to add a gray colored plane of size 3 by 3 cm, enter Add Mesh of Scenario Name, Shape Name. You can also mention its size and color. This command places a gray plane in the scenario. You can add other shapes like boxes or spheres in the same way, customizing their appearance and placement as needed. Now, let's create a robot platform in the scenario using the robot platform object. With this object, you can define and add a robot to the scenario. You can also use it to define the trajectory of an object within the scenario and simulate sensor readings for the platform by mounting sensors like GPS sensor and INS sensor. Let's start with defining the trajectory for robot. You can create a trajectory by specifying waypoints, velocities, and time of arrival in the waypoint trajectory object. Now, let's add a robot. There are several robot models available in the library. You can load the required robot using the function called loadRobot. This function loads a robot model as a rigid body tree object based on the specified robot name. In this case, we chose Turtlebot 3 Waffle Pie Robot. As previously mentioned, let's use the robot platform object to add robot and its trajectory to the scenario. Now, let's add a sensor to the robot and set it to update its readings at the same rate as the scenario. Let's visualize the added robot platform in the scenario. You can see the robot is added to the scenario. To also visualize the waypoint trajectory in the scenario, we can extract the position data from the waypoint trajectory object and plot it using plot3 command. In the similar way, let's also plot the waypoint in the scenario. Now you can see all the objects added to the scenario, including the planes, boxes, waypoints, the trajectory, and the robot. With this, our setup is ready. Now to extract the sensor data from the robot across the trajectory, let's set up the simulation. This set of code iterates the robot through the positions, displaying the scene each time the INS sensor updates. It advances the scene and updates the sensors accordingly. Here is the final view. You can observe the robot is being navigated through each trajectory point at the specified rate. The sensor readings are also being captured at every step. In the similar way, you can also create the scenarios with obstacle avoidance using custom static collision meshes. An example is provided in the description. In this example, you can see a manipulator is performing pick and place operations with obstacle avoidance in a collision object based environment. In summary, this video demonstrates how to utilize robotScenario and robot platform objects in MATLAB to create and visualize simple scenarios in 3D for your projects. Thanks for watching.